Oh. Yeah, that should not be adding a 0 at all to sum. I need to know when we get here with a 0 as that argument, which I probably can't recognize till it is printed. To do break 132 and then run it until you see it printed. Continue, a lot of continues. I should just have printed. Oh, it types in the name of object. Yeah, it's okay. So it's some realize something. With an arc2 of 0. Continue. Product. So no glue actually. It's always a product. This is a sum. I wish there was a better way to set this breakpoint. Hopefully I only have to do this once. Hopefully I don't pass it. Add some. Yes, we got product, some. Product, power, 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 some. Power, some. Product, power, power, product, some. Jesus, how long is this going to continue? Shall I give up now and try something else? This is another sum. Product, sum. Product, power. This can go on forever. Let's see where we are now in main. 236. Oh. Oh. That's basically the end. Okay, let's continue then. Oh, you gotta be fucking kidding me. Exactly now. Oh, this is the first time it prints it. So sum 0, that's what I was waiting for. How can that crash then before before my breakpoint? Don't think I can print this. Can print it. What about that? Yay, I can just print it. Okay, sure. Oop. This is creating a t with the second argument equal to 0, where t is a sum. And that is not allowed. But up. So here again, op t is a sum and arc2 is 0. Still doing almost nothing. There we are. Which add is it? Wait a minute. Was it an add? There was a realize. So this one is returning 0. Which is totally possible, of course. Yep. Should check that. Be quit. Yes. VI. Blink. Ding. Let's call that. Did I do that before? Probably not. I only see results here. Result. Sum 1, sum 2. I don't know. Well, any name will do. Partial. What's this? If constant is 0, partial else it's kind of like here. Here I can just use partial. Yep. And otherwise, yeah, I just have to return this. What is a result? Oh, it's just a temporary everywhere. It's the result of a realize or a combine there. Realize, add anything, as long as we return it. Okay. So I'm going to do here. Print this and return it. Hopefully that works. Cool, it worked. Too much symbols. Or not. Right, so I did add something. I think I added this, which simplified that one, of course. No, I added this. Sorry, yeah, this one was -3, and I added this, which simplified this one because that had minus that also here, and they are still not the same. What is a good next step? Is it not dividing by that? I guess I could multiply both sides with this. Hello, Ghost Monk. I remember the name vaguely, yeah, but I never know what we talked about until you remind me. And let's call this V2. I really have a bad memory, seriously. There's nothing to laugh about. Well, maybe I do if you remind me again. Weren't you the one that asked me before if I remembered you, and then I had no clue, and then you explained it, and I did remember everything. Now I have just Ghostmonk, because that's the only thing I have, the name, and it doesn't trigger anything. I've always been bad at linking words, random words, to memories. It's nothing new, really. What was I going to do? Multiply? I think multiply, right? Multiply both sides with V2. Do. 2. Hello, Leisure DJIBA. Jiba. It's actually pronounceable now I think about it. Well, that didn't work. Damn it. So I have this. I multiply it with this. Surely then we get just that, right? But what happened is that it changed into... Okay, where does the 27 come from? Anyone? This makes no sense whatsoever. I think the program must be incorrect. Nope. Oh, hey, Mark Post. I don't remember anyone. My brain is completely used by coding every day. Every neuron that I still can change is being used for coding. So other stuff just gets faded out after a while. But what nonsense is this? I have this expression, left hand side. Add something to it, I print it. Then let's actually print V2 as well. PODC notice multiplying with V2. And then we print it again. Left hand side is left hand side times V2. And I print left hand side. I forget about the right hand side. I just want... and forget about this. I feel so being let down. What's going on here? Clearly we have something times the inverse of highlighted. Now we multiply with highlighted, and the result that I want to see is that. But now I get this. Why? How? Now there is a small chance that this is correct, but it just didn't simplify, which would be shocking. But let's simplify it with octave then. Octave symbols in it are C1, C2, C3. That's all. Simplify that whole thing. And actually, let's print it. Did I do? It should be understood the way it is printed by octave. Don't? No, that's what I mean. It is 9C1 divided by C3. So apparently my code is just not able to simplify expressions like this, even if you multiply it like literally with what you just divided it by. Yeah, it just... okay, maybe I see what happened. We have this appearing here. That is just left in. So multiplying it with this... actually, there's a -3 now, yeah. So this appears here, incrementing that with 1. And then that part is combined with this, so you get -27, -3 times 9. And then we have C1 times C1 squared. And we divide by C3 twice. And then the highlight still. So yeah. I'm very disappointed. Could do the smaller steps maybe. Why am I even doing it? Because I already know the answer, but I want to have it kind of hard-coded in the code that it at least verifies that it is equal to -3. So that if ever I change something and that is no longer true, then it will tell me. So instead of multiplying with this, I'm going to multiply it with just C3. Really small steps. Sorry, so that's here. So let's multiply, forget about that one, multiply with C3. Make octave, and I keep doing that. I see something short and then my spine hits enter, because I think, well, that must have been the last thing that I did run. Okay, so now that worked. If you multiply this with C3, then this part just disappeared. So maybe I should just work towards this thing first. So I'm going to divide this by 9 and divide it by C1. Can we do that in one go? That is, make this V2 again. That should work, really. That should work. Where V2 is then, I deleted that, right? Expression V2 is then 1 divided by 9 times, and then what was it? C2 to the power minus 1. No, what? Yeah, and C3. I think. Yeah. No. C1. Nobody understands this. I think it didn't get a 1 divided by 9. It's a recurring thing. Have to do constant realize 1,9. Okay, so if you multiply this with 1 blah blah blah, then you think that the left is simply the highlighted thing. Yep, no, that at least is progress with respect to the left hand side anyway. Hopefully the right hand side is going somewhere as well. So now I want to make the inverse of that. So I'm going to do left hand side is the pointer 2, and then we do 1 divided by the left hand side. Take the inverse, and then the same for the right hand side. Print both. Oh, it's going nowhere, is it? It's going nowhere. I'm still having this times that. What? What is this? Oh, this for the whole thing. Yeah, okay. No, this is going nowhere. Okay, well, let's forget it. It's simplified to -3. I'll vary that with octave. Let's see. What I can do though is fill in, I think, a value for C1, C1, C2, and C3. Fill in some really big numbers, and then if we get 0, then it probably didn't depend on those big numbers, because if it did, the big numbers would have survived. So that is an idea there. So I'm not going to do all of this. I'm going to, not even that. It should be equal to -3. Okay. I want to do an evaluation. I can't do that. Actually, I should be able to do that. I can just assign. I can assign symbols, I think. And then call evaluate. I don't know anymore how that worked. So I need an old program to look at. Something that assigns to symbols. So just have a random look at this. Here we assign to AI. What is AI? It's an int. To have a symbol A, and then I can just assign an integer to it. The thing is only working with rationals, only integers or integers divided by integers. And is it an evaluate or something? It's for a function. I can make functions, I know that. If I make a function, then I can assign these things and evaluate it. But I'm not so sure about. So function of one variable. Then. I have multiple variables now. Let's just try the obvious. Try something. So I'm gonna assign T0 is something. Oops. And T1 is something. T2 is something. And G3 is something. Human random numbers. And then you hope that you can evaluate it, but I wouldn't know how. Expression. Expression is just equals not an expression. Yes. Evaluate. I should be doing it. Totally. DC out. DC notice. C0 is C0 evaluate. Yep, -3. Oh, that is pretty cool. So you can say that's coincidence, but I don't think so. I mean, and I could check that it is -3 with an assert, and then have a loop, a looping over this, assigning random numbers 100,000 times. Every time it's -3. But I think this once is enough. Plus, I don't think there was a C0 in it. We're talking about this thing. C1, yeah, there's no C0 in it. This was a derivative. Still -3. Okay, so that was this one. And then let's do get the coefficient of x squared. Expression. Why am I calling that C0? Substitute C0 is C1. And let's call this one C2. Assert that so totally 0. Is 0 because yeah, Ix is 0. I mean, we moved the thing. But let's check it anyway. So constant is 0, C2. And then let's get the coefficient of x to the power 3. Which obviously is 3 equals number 3. And yeah, that should actually be equal to 1. Although I don't think that one got simplified correctly either. So let's do basically the same thing. Oh, that is 1. Yeah, of course. Just never mind. Okay, so we can leave that one out and just test that it is 1. Do we have an is 1? Is 1. We have an is 1. I'll accept that. That is for the C3. And okay, get constant. So now we have the C0 thing of this polynomial. And we can print that out. C0 equals C0. Yeah, that is again an absolute horror. I thought it was it can be simplified as well. So, octave sims. This thing contains everything. Simplify that expression. Not very much simpler. That is a damn difficult, big thing, really. Yeah, so really we want to work with C3, 3 times C1 minus C2 squared. I think. I never know how to do that. So, edgy. So let's introduce a D, which is equal to this. No, the other way around. So this must be equal to C2 squared minus 3 times C1. But really I want to replace C1. So subtract C2 squared from both sides is that, and then divided by minus 3. So divide this by 3. Just divided by minus 3. Two C1s of that. And then I just introduce a new C1. C1x. So we set this. There's no D. Sims D. And then I want to do this to have it still an ounce here, or I just have an ounce. It says ounce here, so. So I want to do substitute in the answer of and just replace C1 with our new C1. It was C1x. And then of course do that again. Let's let's use bar this time. Simplify bar. There we are. I did it. This is what I wanted. So I want to copy this without forgetting what D is. So let's just go to another window. Undo. What did they all change here? Comments. I was reworking this thing. Okay. Comment this out for now. No, actually I would compile. I can just write it. Right, so we have this. Substitute specific style with nothing. Oh, that's not what I wanted. Dollar. And also substitute that with oh, well, this then. So this is what we had, and then also D equals this is what defined my D. But this is just C1, and I multiply both sides as -3. And then add C squared, C2 squared. Okay, let's create that D. T2 squared -3 times C1, and then create that, which should be equal to C0. But let's call this C0A because I'm running out of symbols, variable names, I mean. So that is then something divided by something, where this something is D to the power, and then we need a 3 divided by 2 constant. Constant realize 3 divided by 2, and that thing is 27 times C0 minus C2 to the power 3 plus 3 times C2 times D. Let's print that. Can quit now here. And yeah, are these two the same thing? Well, they both start with 27C0, so that is promising. The highlighted part is completely vanished for this one, but that's because this is the simplification, isn't it? So yeah, we'll never know. Unless... they should be the same. I can just run simplify on both again. I already did it on this one. But no, that's not what I want. This was the most simplified thing. So I just have to check that they are the same. By filling in again, I guess, a few random numbers. The others still have numbers in it, so then we can evaluate both. Let's evaluate both, which means that one of them was C0. And the other one is then A. And then I'll go ahead and add the assert that these two things must be equal. Uh-oh. They are not equal. This one is 66.2 and this one is just 2. Well, that's weird because I started with this and then I did an attempt to simplify it. Must have made a mistake somewhere. Let's try this again then. This thing, copy. Just have to do it manually, I think. Well, semi-manually. C0, C1, C2, C3. Foo is simplify my expression. Display foo. Ah, I remember. Now I remember. Yeah. What I did was I removed the C3 by setting C3 to 1. And the trick is that if you just divide everything by C3, then it's per variable. So in my simplified case, which is this, I actually meant to divide everything by every other variable by C3, like this. And then also for this one, of course. Do it again. And the other same. Blah. Da-da. Ba-ba-ba-ba-ba-bum. QED. I'm not going to try different constants. Just these random big constants are enough. Which means that we can replace the cubic that I have, px3, with, that is a cubic, right? Transform returns a cubic. So I can create a new cubic called px4, say. Cubic px4. Simply with yeah, the coefficients that we use here, which have to start with some symbol, but okay, x. And then the expressions, which now the favorite expressions is C0a, and then C1, C2, and C3. Which was printed last time as px, and then I'm still saying that it is that. The why not thing. Okay, I could say which simplifies to well, what you call simplify. That is totally not what I had in mind. Damn it. C2 is 0, yeah. Well, might as well pass 0 then. And C3 is 1, so I might as well pass 1. And C1 is a complex, and I should have passed -3. So this is 0, this is 1, and this is -3, which never will work. Let's just make it again, if I don't already have it. Constant realize -3. Poo-poo. Okay, so now we have a simple tail here. And an absolutely horrible constant. Now, one of the things that we can say, what I did now is shift it horizontally and scale the x-axis around the origin to this wider or narrower. And but that's it. No, and there was another one. Yeah, and divide a polynomial by that again, which is theoretically a vertical scale as well. But okay, both are defined by the x-coordinate of the local extremes, and then that forces the local extremes to be at -1 and +1, which means that you just have to get this. But if the original inflection point had an IY of 0, then that should still be 0. And that's something we can check, because that means that if the original has an inflection point at y is 0, then this should be 0. And that inflection point is filling in this into the polynomial, which is, didn't I already do that? No, I didn't. Seems something for octave again. Okay, octave. Seems C0, C1, C2, C3, and X. And I want to define my parabola. P of X is the parabola, where of course we use the normal exponentiation. And then we get the P of IX is the substitution in Px of X with the Ix, which is this. Warning. Just display. I have no idea why I called it Pi of X, because this is Y, of course. It's the Y coordinate. Yeah, too bad. So the Y coordinate of the inflection point is that. Now if this equals 0, then this expression must be 0, right? So what we can do is just make it 0 by, let's say, setting it to 0 and then solving C0. So I make an equation. Equation is that thing equals 0. And then we solve so whatever solution solve. No, come on, that is C0. It is the solution of C0. Solve the equation for, well, C0. So we can display that. If you make C0 equal to this, then this thing should be 0. Well, I believe that, right? I mean, so divided by, so what is divided by, really? It looks a bit weird. It looks very weird. So again, so C0 times I divided by C3, okay, and again and again, in which case the IX is not correct. This is for the case where we didn't do that. Or actually, no, then it becomes C2, but the C2 is this. So yeah, no, that's probably still correct. Zero, okay. Oh, I was looking wrong. I don't know. Is it bedtime? I thought these things didn't match up because I was confusing the 3 here literally. Did you see all those 3s and 2s and I didn't, I don't know. So what you want to have always is a matchup of C3 with the rest. So you have C0 divided by C3. And then we have a one C3 for the C1 and another C3 for the C2. So this is just C1 divided by C3 times C2 divided by C3, all divided by 3. And here we have C2 divided by C3 to the power 3 times 2 divided by 27. So they do match up. This doesn't match up though. Oh, but this is a C0. So this equals C0. So I divide the the C0 by C3, then I have to divide this by C3. And then we have C3 to the power 3, which then matches up with this 3 and these 3 again, so that it works outside. The units work out, as it were. Okay, I forgot what I was doing. Yeah, so if I set C0 to this, then yeah, then this expression must be 0. So let's try that. So that thing is actually the constant one. So let's call it capital C0 again. And then we're going to do simplify and substitute in this C0 the C0 yeah, that's exactly one C0 here with the solution. And it is 0. Yeah. Okay. Ta-da! That's pretty cool. Well, then I guess we did something that verifies it. I mean, it seems to be correct. It's just a very big formula. So print, quit. Doesn't look that big here. Okay. No. I think this is still a good idea. Otherwise, you just have to do way more calculations. And in the end, I was already getting abbreviations done by just dividing everything. You know, C0 divided by C3, C1 divided by C3, and so on. I don't think there's any speed. I mean, after this, you just got rid of C3, basically. So that's a good thing. But that means that now I mean, the C3 is now 1, basically. So good to remove the C3. Yes. And this is just to the power 3 divided by 2. Turn this into a comment. And I think I want to have this one as well, right? So we make a double, which I call D, there's why not, which is then the square of C2, which let's use utils square for that. And if anyone wonders why the fuck I would do that, isn't that slow or something? Well, this square is defined as this one. If T is a built-in and double is a built-in, then always inline this, aka it's just literally argument times argument. Absolutely no difference whatsoever. So I could type C2 times C2, or I can type this. Same assembly, same speed, everything. I just like to type square instead of. Maybe I would even more like to type caret 2, but yeah, that is problematic. Okay, so we have our D. And then we can define this constant. Yep, so now the double. Shall I call this capital C0 will do. Is 27, we work with doubles, times this C0, already removed divided by C3, minus, again, the square of C, oh, it's even the, sorry, that's even to the power 3. I think the compile, I could do the square separately, do I need it? No. Yeah, actually, it looks suspiciously like C2 times I want to do the C2 times all of that, which means that, oops, it means that this one removes and this one gets 2. And then we have again that same thing, you see. Square of C2, oh no, it's plus, okay, whatever, never mind. Anyway, let's use the square again. Put it on that side. And this means that we divide it by d and the square root of d. So maybe I should just do d times the square root of d. Now we have two minus signs that could lead to numerical instability. If this gets close to 0, then we have a problem, and if this gets close to 0, we also have a problem. Although I doubt that we can make that go away actually. Now the square is of course positive, so if C1 is negative, then we don't have a problem here. Okay, let's think about numerical instability later. I'm gonna just go with this for now. Okay, so this formula already incorporates the inflection point shift. So this can be removed, and this can be removed. D was just a temporary. Maybe this requires a comment. Okay, transform the cubic into... Now let's bring the primes back. Well, no, I don't like primes because that looks like a derivative. I'm gonna use Q. So the Q of... Yeah, but in this case you do X prime. No, let's call it, let's use U and V instead of X and Y. C0 plus U times U squared minus 3. Did I do that right? Or did I do that right? Yeah, it is x times x squared minus 3 plus that, which is C0. And now we use U. The beauty of all this is that now you have no longer this shape, only this shape, but it can still be vertically shifted. So it's one of these four now. Okay, I really need to know if I committed this already. Otherwise, I'm gonna rewrite the whole thing. So, div. It's not going to work because I have to div math. Get div. Nope, I never committed it. Or did I? No, I have a lot of changes I did not commit. Shit. So stupid. I think that is new, and the rest is then untouched and should still be working, which is probably the easiest to see by running that program where I can just drag points around and it draws piecewise Bezier curves, which was God knows what name that was. Maybe this one? No, this one. Oh, yes, and it seems that it still works. So this curve was divided into piecewise Bezier curves, and well, if I completely broke it, then I would not have done like this. Plus, it even works, you know, like, well, the same way. Sometimes it gets broken, but usually that looks good. So, and we can also see here, I think that see the Newton-Raphson, but then Haley method takes a few steps. Normally it takes 2 steps, now it takes 3 or 4 steps, but that is because I changed that to running until there is absolutely no progress whatsoever anymore, aka floating point round off error precision. 14 digits stability. Well, of course, we don't need 14 digits. We just need something in the neighborhood of a pixel. So I think four digits would be enough instead of 14. But yeah, maybe I'll add a resolution thing. I think by the time I'm done with this, it's just going to be infinitely fast, having a 14 digit anyway. So might as well go with that. Okay, everything still works. I should commit this. Git status. Oh boy, well, can't commit without looking at the diff. Why did I comment this out? This bracket algorithm. Oh wait, bracket or Newton's is printed here in Bezier curve, and commented out probably because it was too verbose. And here I discovered that standard hypod exists, so I thought let's use it. And that's a new fan. What is this? Oh yeah, bug fixes in symbolic. And what is this? Yes, yeah, well, work in progress fuck up of the test program, because I wanted to abuse it for something else, so maybe I should not commit that. But on the other hand, it's probably not committed. So the old way to do it and the new way to do it. So this is just testing something, and I added it in this program because that seemed convenient. But and then we have random cubics and cubic roots. Okay, so that would be this thing, which I'm basically still working on, but why not commit it? And that one. This generates random cubics. Gonna commit it as well. That doesn't look like I want to commit it or even keep it. Image or PNG. Just remove it without looking at it. And output SVG is probably some chest thingy or something. I don't know what it is. This is what it is. Okay, remove. Sampled distribution. Yeah. Not going to commit it yet. Orbital. Out. Heli.m. Probably also not super interesting. Yeah. Well, Dunk looks like I can remove it, but now I'm curious. Cubic. Oh yeah. Yeah, no, okay. It's probably just a test for the sampled distribution thing. Gone with it. What is this? Test M. Yeah, that was a while working on transform, I think. So we worked it out already. Transform is finished. Probably the same thing for test 2. Shifting stuff. See, that's annoying. And when I did this, I was like, maybe I make mistakes, so I write an Octave program that does it, and then I know for sure that I don't make mistakes because these things are all generated by Octave. And then lots of effort into printing on this. And by now, I just memorize those things. I mean, come on, I know this from my head. It's just I saw it so often, and then I see this and it's, yeah, I mean, trivial, you know. I can dream this by now, so let's delete it. And then the bad thing is that with my memory, in a week, I will have forgotten it. So now, when I look at it, it's like, yeah, come on. I mean, everyone knows that it is minus C2 divided by 3 times C3. So probably I made C3 1 here. So, yeah. Therefore, I delete it. And I'm going to regret it, because later on we'll have forgotten it again. But yeah. I don't want to see this thing. Let's not delete it, but let's move it down to the lowest machine learning, which is not in the repository. What the hell is that? Probably something written by ChatGPT. I think it was drawing something. Oh, beautiful, isn't it? Yeah, we don't need it. Don't need it anymore. We'll ask ChatGPT again. Do I have something like Inkscape that can draw these things? No, apparently not. Documents empty. Totally empty. Okay. Begun. Shortest arc length. No one knows who created that empty. The to-do has been here for a while. Not going to commit it. I think I'm done. Now I can commit this. Commit everything. And then we think of a good work in progress comment. And then I go down, get status. And then we do get diff, because this is what I really wanted to commit. Oh, Gangan roots. Oh boy, yeah, iterations. Yeah. In the end, I don't want to have that even, let alone commit it. But right now, I needed it to. Yeah, for debugging purposes, basically. I don't even want to have it in the end for debugging purposes. Can you imagine? Well, fuck, I'll just commit it anyway. Git status, git commit everything. Wait, is that going to be added automatically? Yeah, probably. Let's try it. Commit -a. Whip on cubic polynomial get root status on track content. Okay, that's a to-do. Now committed it, so now we can finally really work on it. Cubic polynomial cxx get roots, and this is what I was working on, so we uncomment it again, and then the idea is that now this is no longer relevant, these cases no longer exist. Is extreme, return the ice inflection point. O is the root that we'll try to find. This method using starting point x. Starting point is set the slope. Cross x as a positive local scene closest to O. Past that local scene that is closest to O. Starting point is set on the slope that crosses the x-axis. Oh yeah, okay. In all cases, initial starting point is 3 times the inflection point x coordinate minus 2 times the extreme x coordinate. Determine if the inflection point is above or below the axis. And we're going to replace all the coefficients with our new variables here. C0, C1 and C2. No, I want to use this one. So really we just have C0. And C3 is 1, C2 is 0, and C1 is -3. So this was C0, and what do they say? C2 0. We don't have an x squared anymore, which means that all of this, seriously, all of it? Oh, okay. What? Okay. Might as well remove the 13.5. Whoa. Okay. Coefficient. C0. And then here we have coefficient 3, but it equals 1 to 1, which then means that this of course is true. True if true is equal, so just that. Can remove these. And then we have these. This is 1, so that becomes that. That is definitely not what I want to do. No, I have to write that out. So this is now C0 plus x times the square of x minus 3. I can change this as well. The inflection point is 0 now. My whole a cubic is probably, yeah, it's using this. That's not what I should do. Change that. Inflection point is, yeah, this is just 0. Let's remove it. So this is 0 anyway. And the extreme here is plus or minus 1 in our case now, depending on, but I guess it depends also on that. So I already fixed this. Gee, yeah, of course it does. Extreme, so it's either this extreme, which is at minus 1 now, or this extreme, which is at plus 1, and that depends on the value of the inflection point. So if the inflection point is y is larger than 0, then we must use minus 1 for the extreme. Larger than 0 means minus 1. So this is that. Yeah. No. This is the starting point. Dude, I just want to start at plus or minus 2, apparently. And that is, I want to start at minus 2 if the inflection point is larger than 0. So there's something went wrong here, because this is minus 2 minus 1 is 2. Let's just remove that and then say minus 2 and plus 2. So the inflection point y larger than 0, then we want to use minus 2. Yes. And in the other case, we use inflection point x, which is 0, and then I use plus or minus 1, which is ridiculous. Well, not ridiculous, but arbitrary. So I might as well just always use that. I don't care if it has extrema anymore. Ta-da! Don't you love the simplifications that we get. Okay, and then we have here, this is and that is 3 times x. Yeah, but you can see 3 is 1 half fppx is yeah, c2 is 0 now. So this is the same thing as that. Yeah, I don't know. Let's begin with that. fpx is coefficient of 1. This was 0. Half ppx times x. What was coefficient 1 again? That's minus 3, right? Yeah, that is minus 3. So I can do this minus 3. Apply Haley's method. Now we get a root out, but I have to transfer that back, unfortunately. And then I can do this, find the other 2 roots. Long division, the remainder, that's just of the current thing, which should work. Number of roots. Okay, I think I can leave that. Just this x here has to be converted back to where it came from, which depends on the transform that I did. Okay, I have to figure this one out. There's a slight problem here. For some reason I ended up with x times x squared minus 3, which always has extremes. That's of course not possible. Well, where did we go wrong? Yeah, can't help it. Right now, this is always true, which is bullshit. And then at least I don't need this anymore. Well, this. Now I need to know how to transform my x back. Where did that came from? That was was working on this. This program does a few transforms. Most notably, it should only do transforms. Yep, to divide everything by C3, transform. Shift the inflection point to 0, transform. And scale the x-axis to get the extreme at plus or minus 1. That's another transform. And the rest is just some testing. Test. Okay. So if I just print here the transforms what we do. Notice transform. Scale. Y scale. Shift. Y shift. XP. So now we can see divide by C3 and then shift the x-axis by that. Now this doesn't change the roots. There's no reason, if you only do this and then calculate roots, it doesn't matter. This of course means that we just have to add it back or subtract it or whatever. Subtract it, yeah, but subtract this from whatever we found. And this one is the most complicated one. That is, well, actually not even that much. I think the Y scaling is absolutely not interesting. Again, so we just have to scale it back with this factor. Beats me, we have to divide by it or multiply with it, but let's see, you can figure that one out. It's a square root of something. hell does it mean? Scale X. The original. This is where the extreme was, and I wanted to end up at 1. So I divided by that. That obviously means that we have to multiply it by this to get that 1 back to the EX2. But the thing that I have now is this value. So I have to divide by this value in order to get it back to where it should be. So we have to divide it by this, but yeah, that's to the power minus a half. So let's just invert this thing. So I get 1/3 and plus a half. And then it's multiplying. Back by multiplying with and nou ja, adding the thing that we have to add is this one. So we added this, or rather let's concentrate on the ix one. So the 0 must go to that value, which means that we have to add this value, which means to have to subtract that value, which was printed as this. So we must subtract this. Yeah. Which means we must add this. This was called scale. C2 divided by C3 squared. This, yeah. What? C2. And this is C1 divided by C3. Except that's not true. These are the originals, so the coefficients. So at this point I have a C2, which is already divided by the C3. actually keep the constants together. So C2 divided by -3. And this C2 is actually C2 divided by C3 already. So this should be it. I'm gonna make them const. So multiply by scale and add offset. Oops. Now drum ruffle compiled, so that's one thing. To be honest, I cannot imagine that it works, because that was a big change, right? And it doesn't. Well, I had not expected to crash. Yeah, we have to be a little bit more careful, I guess. Let's use another program that is just about cube roots, maybe? What does this even do? Is that even calling what I just changed? Nope, it's not. I need a program that calls get roots. Random cubics maybe. That depends on what the polynomial is, but cubic Bezier 2 is also polynomial. No, it's another thing. I think this one then. I'll comment it out. Oh, I can use this one. I can definitely use this one. This is the simplest. So this one just takes this cubic. What? That's not a cubic. X to the power 3 plus. And then get 3 roots. And they are printed. Okay. And that is an abuse of random cubics. There's only one root at minus 5.7. Plus it didn't print any debug output. Very suspicious. Get roots. Math cubic polynomial get roots. Yeah, it is the function. Okay, let's GDB. Step into this break main run. Math cubic polynomial get root step. Yeah, without iteration, so with iterations. Notice train cubic polynomial get roots for that thing. That looks correct. If that is 0, no, it is not. C0. Okay, that's okay. So that everything is divided by 1. That shouldn't do much. It's got the same values. And then we calculate a D value, which is some value, and a C0 value, which is, I guess, also a non-zero value. Pretty big one. Why so big? Okay, that doesn't seem to make any sense whatsoever. Mm-hmm. That does not seem to make any sense whatsoever. It's probably useful to know what the values should be. Oh boy. Probably, well, what's it? Not probably. It's time for me to go to bed. So yeah, maybe for tomorrow. But these values are all pretty normal-ish, and even that one is that. So this big value says it's impossible. It's never, not gonna happen. Don't think it's wrong. And then of course you get nonsensical roots as well. But so yeah, the idea is that let's just try to do something quick. Haha. Asking ChatGPT. Oh, quick. Yeah, let's waste some time with just start over and okay, let's do the following. What is the inflection point of not what, but where? Just X value is enough. And now it's going to print 3 pages of formulas probably. The beginning is stating that the inflection point is the point where the second derivative is 0. Oh, wow. Wow, short answer. Cool, not bad. Not bad at all. Okay, so, and then we can verify that because that should be minus this value divided by 3. So this value divided by minus 3, which is minus 5.765. Minus 5.765. Yes, it's totally correct. Now, and then I'm going to say substitution for, okay, substitute, I can't type. Substitute x with something else, and then of course I want that if x equals that value, Yeah. Yeah, I'll copy it here. Plus U. So now, if U is 0, then X is that inflection point. So we replace, we move the inflection point to 0. Yeah, that should get it. Okay, well, the U squared disappeared, so it's more or less believable. I'm just going to assume that it did everything correctly, but you have to go to bed. Otherwise, you verify, very. Yeah. So now I want to scale this such that, okay, let's say ask Wolfram alpha for the no, I don't want it. Damn it. Oh yeah, wait a minute. I want to know where the okay. For which U is the derivative of that f of x. Fuck that. Fuck you. 0. It should give 2 points which are equal to each other except for the sign. Otherwise it did something really, really wrong. Yeah, now I put the U there. The hint has been taken. Derivative. Solve it. And to get plus or minus something. Very good, very good. I hated that it abbreviates stuff to only 3 decimals. I can't even copy that number. I can copy this number. Yep. Does the thing have a square root? Yep, you have a square root there. Square root of... Really? Why can't I not paste here? That is so ridiculous. How to do that here? And then square root of... Well, and I lost it. This number. So lazy. Do it with Google instead of copy. Okay. Don't give me short things. Now we know what that is. And I want to scale substitute u is v, and now I want that if u equals this number, then v must be equal to 1. Is that a multiplication or division? There must be a multiplication. Oh, I meant the other way around. But maybe it's smart. No, no, it's not. Sorry. It will normally would it the other way, but this looks easier, understandable. It's just going to replace you with that now. Otherwise, you would of course say substitute. I think v is. Okay, so we had the f of u. Yeah, this. So now it must replace this and this u with that v. Simplify. Where's my question? Here. Proceed. U. Yep, that's still the thing. So it just fills it in. Substitute use that. Repeat. We're only paying for the token, so who cares? Well, not really, but still, actually we are, probably, indirectly. Did it do that? That times u plus that to the power 3. Yeah, okay, and then let's assume that it can calculate that these days. Using a calculator, really? It has a calculator. Oh, looks good actually. It's about a third of this, so that would be 0.09-ish. But it is less than a third. So, okay. Simplify the function. It's doing it again. Yep, it's doing it again. The f of u. Yeah. Maybe it's onto something. I just want to have my function. It's function of v. Okay, apparently this. Okay, let's have this verified as being as having the derivative equal to 0 plus or minus 1. Oh, it already says that. Derivative of this function with respect to v0 when? Yeah. I thought we were working with 6, 7, 8, 9 digits of precision. And it can't get it better than 2 zeros. That is not very precise. How did that happen then? It's not a calculator. This is so bad. I mean, if the thing had a tiny little bit of intelligence, then it would have understood the whole point of this substitution is to bring these points to plus or minus 1. And then it should have been like, oh my god, it's not plus or minus 1. So where did I make a mistake? But no, it doesn't get it at all. Okay, so I want this then to be divided by that number. Okay, and I don't know, let's copy it like that. It's probably absolutely horrible. No, not even. V plus that times v to the power 3. Divide the polynomial by that number, just to make it what was it, monic? I think so. Now, I would have been impressed if now it said, what do you think I am? A calculator? Because I'm just asking it to divide two values by another value. Now, as you can see, this should have been minus 3. So we get v to the power 3 minus 3 times v minus some constant. This is my C0. So, well, plus or minus 1% apparently, but 6658, say. Not this. So I'm going to type in, it should have been 6658. And then I'm going to bed. Undivided command shoot. I'll be back tomorrow. Good night, peoples. Wait. Minus. To bin, I mean print minus that. Yeah. Just for kicks. Fuck, this board so quick. Why? So delta x becomes larger than the previous one. I just never expected that, I guess. I mean, that's why I bought here. And that should never happen. I don't believe it. Yeah, I have to go to bed. More work tomorrow. Good night.